Contamination from stormwater runoff is one of the leading causes of water pollution. It's especially a problem in cities where storm and sanitary sewers are combined into one system. One way to address the problem is to control the amount of runoff through the use of green infrastructure. The DEP's Sarah Alford joins us now with one project that's taking an innovative approach.
Kathy, we're here at the rain garden outside DEP headquarters in Charleston. A rain garden helps absorb and filter stormwater runoff, reducing the amount that would go down the storm drain. A new project at Marshall University is taking that idea to a new level, literally several levels up to be exact. From the outside, the science building at Marshall University doesn't look that different from its neighbors. But step around back and go up a flight of stairs and you'll see what's so unusual. It's called a green roof, living plants actually growing on top of the roof structure. Here's Dr. Chuck Somerville, Dean of the College of Science with, well, the science.
A green roof buffers when rain falls on an impermeable surface like a roof. Typically it would run right off. Places like Huntington have combined sewer systems. So stormwater runs into the same system that sanitary sewage runs into. When that system becomes overwhelmed in a big rain, it overtops the weirs and goes right out into the river. So what we're trying to do is buffer stormwater so that it has a residence time on land or in soil or in plants before it hits the stormwater system. And when you have that buffering, you decrease the height of that hydrograph. Water gets to the stormwater system slower. The stormwater system has a chance to respond, and that combined sewage doesn't have to end up going out into the river.
This is actually just a small demonstration project, something to show off the technology and help the university prepare for a much larger installation on the top floor of the new Applied Engineering building across 3rd Avenue, currently under construction.
And it's also going to be set up for experimental purposes. There'll be multiple drains on that roof, and each of those drains will feed into a laboratory inside the building. So we'll be able to measure water quality, water quantity coming off the roof. We'll be able to get an idea what the buffering capacity of that roof is. You know, when rain falls, how much of it we capture and how much of it eventually comes through. So we can actually plant different types of plants in different plots, different sizes, different types of soil, and then see how that impacts the stormwater coming off the roof.
But installing a green roof is more involved than just adding dirt and plants.
With older buildings, retrofitting is very hard because the green roof is very heavy. This one, they're saying it could be up to 30 to 40 pounds per square foot. So new construction is much easier. You can build it to withstand that. Older infrastructure, it's not as easy. So you have to make sure it holds the weight, that it has no leaks, so you have to do flood testing on it. We had to actually put down 2 more barriers on top of the original roof. So it's not easy, but it is definitely doable.
Plant selection is also important. The rooftop setting actually creates its own microclimate, depending on the location. Designers select plants that are shade tolerant or prefer full sun, but most importantly, plants need to be low maintenance and drought tolerant. And then there's the weeding.
We'll have to continuously weed it. We'll have to make sure that the weeds that float in there do not overcrowd the plants that we've already planted, kill them out, and kind of make the rain garden or the green roof unpleasant looking. So roughly once a week, once every 2 weeks, we're going to have somebody go out there and weed it, make sure there's nothing growing that shouldn't be there.
Green roofs can also benefit the building in other ways. Plants shield the roofing material from UV light, slowing its natural deterioration and extending its service life by as much as 3 times. Plants also provide a natural cooling effect, reducing utility costs in the summer. But that's not the biggest benefit.
A lot of folks don't know where their water comes from, and they don't know where it goes when they flush the toilet or when it goes down the drain. So this is our opportunity to reach them about what happens to their stormwater and why it's important that we try to manage it in the best way possible.
And that learning experience extends to the university too.
Well, a lot of things with green infrastructure, it's trial and error. So if we can practice on this one and keep this one up and running and the way it should be, then we'll just transfer that method, our knowledge to that, over to a bigger standard, and it should should transfer fairly easily, just on a bigger scale.
Travis hopes that Marshall's Green Roof project will help show that the technology is a viable option for stormwater control. Kathy, he also hopes to see more of them sprouting up around the state in the not-too-distant future.
Thanks, Sarah. Construction on the new Applied Engineering building and its green roof is scheduled to be completed in the spring of 2015. West Virginia University is also in the green roof business. There are 4 green rooftops installed on Brooks Hall. WVU's green roof project was constructed in 2007. These photos from 2009 show what a well-established green roof looks like. For more information on green roofs, you can check out our website, dep.wv.gov, and look under the Division of Water and Waste Management's Stormwater Programs page.